I'm going to introduce some SQL code to you. You don't need to be able to create any of this code, and you don't need to even understand it completely. The purpose of this is for an overview, to give you a brief overview of the SQL statements. We'll look much closer at each type of statement and all the details of each in the weeks to come. Let's download the winter database. Let me drop it here because I already had it. So yours, you won't have it to begin with. And let's go. You'll probably see an activity that goes with this video to get that SQL file. Make sure you're in Workbench and then click File and open SQL script. Find the file that you downloaded and click Open. Don't just go to Downloads and double-click the file from the downloads, because it might open up without a server connection, or you might open it, the default editor on your machine might open it by default instead of Workbench. So use the File and the Open SQL script to open up that downloaded file. Once it's opened, you should see a bunch of code that might look very foreign to you. This is just a file that has all the code and data needed to create and put data into a small database. This is the same kind of data that you all collected that first week of class. This is actual data from one of my winter semester classes, and I have changed the name of the students. Before we run this, which will create and populate the database, let's look at some of the code. Some of these statements fall into the Ddl category of statements and some into the DML category. So let's just look here. So here's one right at the first. And this one is creating a database. So this statement is DDL, and it's a line that creates the database called Data Winter. This is an example of a Ddl statement, data definition language. Ddl has to do with the actual structure of the database itself. So this statement creates an empty database called Data Winter. Let's see, this next statement here is also DDL. Let's see, that this one, it creates the table of the database called image. So again, DDL having to do with the structure of the database, adding an actual table to the database. Now if you come down here, this insert statement, and it's a really long one. In fact, if I turn wrapping on, you'll see how long all that data is. It's inserting some actual data. So this insert statement doesn't really affect the structure of the database. It's just getting data into the database. So it is not DDL but DML, which stands for Data Manipulation Language. And all of the select statements that we're going to look at next will also be DML, because it won't be affecting the structure of our database, just retrieving data out of the database in a result set. It's also good to know that, actually, let's go ahead and run this. And I clicked on the lightning bolt, which means it's going to run everything on the page. And if I refresh my database list, my schema list, it should show up and you should see Data Winter over here. All right. It's also good to know that none of these select statements that we're going to be doing are going to change the original data in the database. We're just going to retrieve the data that we want from the database. Before we run the select queries, let's make sure that we're using the correct database. You can double click on the name of the database in your schema list and make sure it's bolded, or you can just say use and the name of the database and make sure you run that, and it will also select the database. Make sure you're using the right one. All right, let's try a select statement. When I run this one, you'll see I get all of the data from the student table. The asterisk means every column in the table. Select and from are keywords, and it is best practice to capitalize them, even though they don't have to be. Student is an identifier that represents the name of a table that we're going to be getting the data from. This query has two clauses, each beginning with a keyword, the select clause and the from clause. Let's try another. So now I'm writing instead of the query or instead of the asterisks, I'm replacing it with column names. I'm adding more identifiers that represent columns in the table this time. So the columns down here are the same by the same name. This would only get 3 columns from the table. Each column name is separated with a comma. Notice how I've been ending each statement with a semicolon. This helps differentiate one statement from another. I have 2 statements, or 2 select statements, 1 use statement on here now, and I want to make sure each one has a semicolon after it so that they aren't seen as one statement. If I want to save my statements at this point, everything on this one tab can be saved in a file. If I say File, Save Script, and then I could just go ahead and name it and save it somewhere. It would have a .SQL extension. It's also important to know that you should only run one query at a time, or one statement at a time. In Workbench, if you click the lightning bolt, the execution icon without the insertion point, it will run every single statement on that current tab. So all 3 of these would run again. I would instead use the icon with the insertion point and to just run the statement that has the insertion point in or close to it, so like this one does, or use the keyboard shortcut Control Enter or Command Enter on a Mac. You could also highlight just what you want to run and then use the regular lightning bolt as well. But it's important just to run one at a time, not run everything on the page every time. All right, let's add a filter to our query. Now it's only going to show those students who have, I'm going to hit Command Enter, only those students who have a major of CIT and no other students. The string CIT is placed in quotes because it's a constant or a value from the database that happens to be a data type that's a string or character. String values will have quotes around them. Let's add a sort to our query. Now, if you noticed, there was no order to the results except for maybe how I entered them. When I ran it, now you can see it's alphabetized by last name. All right, let's try another one. Let's say get all the last names and first names from the student table where filter the distraction category is equal to internet. So we're looking at which students had internet as their top distraction. I'm going to run that, and we'll get all the students here that had the internet as their distraction category, their top distraction. Now remember, from the ERD, that we saw with this database. The distraction category was an enum. You can see that down here, how it was designed. So the data entry is going to be limited to only those words. These are only available words that can be used. So when we ran that query, we got all the students for sure with that category. But what if we change it to distraction category? Now notice worry category. Worry category is varchar. And it leaves it open to data entry person to put any string in there as long as it's not over 45 characters. So let's go back and change it. And let's go ahead and put worry category. Just changing it to a different column. Of course, internet wasn't a worry, so we're going to change that to family. Okay. Now we can see every student whose top worry was family. And we get these 5 students to show up. Notice, though, if I go back up here and show everything from student, we have Brandon right here. Is it Brandon? Hold on. Yes, Brandon. It's this one right here. Okay, so now notice Brandon says his top worry is about his wife. Now that wasn't one of the categories. Wife is family, and family was one of the categories on the data gathering sheet. So data type does matter because now Brandon is not going to show up on this query. Even though really he does worry about family, he doesn't show up because his data was entered a little bit off. So data types matter if you want your result sets to be exact. Now, remember, the purpose of the select statement is to get the data we need to make our decisions from the database. So think back to our statement of work. What kinds of questions might the app developers need from this data to make an effective app for college students? They probably don't need to know names of students or groups, but more overall data, like the answers to questions like what is the top distraction category for all of the students, or what is the top worry for all the students. That code could be placed in a query that looks something like this. Notice the comment at the top of the query. The dash space, it's right here, tells the computer to ignore anything past that on that line. So it's going to ignore anything here. And it's just going to keep running the query. It's just a note to the developer, to myself, so I remember what the query is doing. You could also use a hashtag at the beginning. My computer keeps freezing a little bit. Hold on. And that would do the same thing. You don't need a space after that one if you don't. All right, so this one is what is the biggest distraction? So if I click that, you'll see that now there are some more keyword. Well, let's look at the words here. So there's more keywords now that we haven't seen. You know, we've got count here, we've got group by, we've got order by, we've got descending. And basically, I'm not going to describe what all these are doing, but it's basically adding up every time it sees a certain distraction and putting that one distraction and counting it up and putting the one that's counted the most at the top. Notice that only the categories that were limited by the enum are there. All right, so let's try the worry one. And run it. And you'll see we get a lot more categories because it was varchar, remember. Even though I told the students to enter it in by the categories on the data gathering sheet, they didn't. And that's true of most data entry. It will happen. So notice also there's even misspellings on here, like this one. really should have been another count toward this category. So that's the risk you take for using the varchar. If you have specific categories, you know that they'll fall into. But it works the same way, showing the biggest worry on the very top. The last few of these queries are just some queries that use more than one table of data. For example, if we wanted to know which group in class, in section 1 class, had the most selfies, we'd have to go from the group name to the student table to the image table where it talks about selfies and include all those tables, every connection it has through there, in the query itself to get data from 3 different tables. So you see there's different tables here, here, and here. All 3 of those tables are represented on here. And so then we can see, let me run it, that group Uno players had the most selfies in that class. All right, so there is a quick, brief overview of select statements. This is what we're going to be spending the majority of our time on here in class. So I wanted to go over them briefly this week because the next few weeks we'll be going over database design, and we won't see a lot of select statements for a few weeks, but they are going to be a huge part of this class.